Continuing with our notes, now we're going to focus solely on Boyle's law. So Boyle's law, which we already wrote down, states that volume and pressure are indirectly proportional. Hopefully you got that from your last assignment. Right? That basically means that your graph hopefully looked like this, showing that it was inversely proportional. Oh man, sorry. So what does indirectly proportional mean? It means if one variable increases, the other one decreases or goes down. So that means in the case of Boyle's law, right, if there was less space, um, if the volume decreases, those particles that are moving, they're going to hit the walls more often. They have less distance to travel. And so when they hit the walls more often, and every time they hit the wall, they cause pressure, the pressure goes up. Right, so decreasing volume of the container of gas that it's in means that you're going to increase the pressure. Now, if you were to go somewhere in your house into a smaller room, that doesn't mean that the pressure is going to increase, because in your house, right, the air can go everywhere. Even when you close the door, it can go under the door. So everywhere in your house, regardless of room size, the pressure is the same. It has to be in a confined container. So increase in the volume decreases the pressure. Right there, it's an inverse or an indirectly proportional relationship. As one goes up, the other goes down. So there's our equation. When you get to the final exam, realize there is an equation sheet. So that's nothing that you have to memorize. It will be given to you. So our P1, V1, so if we have a container full of gas and particles moving around, right, all over the place, that if this is the volume of our container, that's our V1, and then the pressure caused by those particles is our P1. And then you're going to see that something's going to change. They're going to possibly decrease the volume. And now when they decrease the volume, which would be our new V2, these particles that are in here still moving around, they're going to cause more pressure, right? Because our volume decreased. So because our V2 is now smaller, our P2 will increase. And it just gives us a way of calculating that out. So we got two examples to do. A balloon has a volume of 0.67 liters. So I know this is one volume, and a pressure of 12.5 atms. So these two go together, right? It was a balloon at this volume and at this pressure. What will the new pressure be? So I'm looking for P2. What will the new pressure be if the volume is decreased to 0.51? Well, this means that's our new volume, V2. I find it helpful to write down the information before I put it in an equation. You're not required to do that, but you might find it helpful. Also, if I didn't even read this thing at all, I mean, if you look, darn it, that's not what I want to happen. There, that's what I wanted to happen. I want to be able to change my pen color. If you look just at the units alone, well, what do we measure in liters? That's volume. What do we measure in ATM? That's pressure. And so you're able to figure out the sum of what these numbers mean just by looking at the units. Now, the key here is the units for volume, they don't matter, but they have to be the same. So because we're liters and liters for volume, it's good. If it was milliliters and milliliters, or centimeters cubed and centimeters cubed, as long as they're the same units, it doesn't matter. And the same thing goes for pressure. So if I have a pressure in ATM and I'm solving for what's the new pressure, that answer is going to be in the units of ATM. So this is what you are required to do. You are required to write down the equation. So you have to do this to earn all your points, and you'll see that written out in the rubric, the grading rubric. Number 2, you have to plug in your numbers. And number 3, you have to have an answer with the correct number of sig figs and the unit of measurement. You do not need to show me your work. Right? I don't need the algebra steps. I just need the equation, the numbers plugged in, and the answer with correct sig figs and units. Right, so P1 V1 equals P2 V2. We know that these are our P1 and V1s, so that's what I plugged in right in my step number 2, 12.5 times 0.76. And then I'm looking, I also have my V2, so I plugged that in, right, my 0.51, and I'm looking for P2. Now it's just algebra. So how are you going to solve that? 12.5 times 0.76, right, is 9.5. Then you're going to divide this 0.51 over to the other side, so 9.5 divided by 0.51, and then you're going to round to sig figs. When we look at our problem, this is 2 sig figs, 3 sig figs, and 2 sig figs. So because 2 is the least amount of sig figs, I round my answer to 2 sig figs. Right, and remember, because it's pressure, it has the same unit as our other pressure, ATM. So here's another one. A bag of chips has a volume of 2.1 liters. I know that's a volume, right? Liters. And a pressure of 1.2 ATMs. So that's our P1 and V1. The bag is brought up to Flagstaff, where the atmospheric pressure is only 720 torr. Uh-oh. These two units are not the same. So Flagstaff, where the atmospheric pressure is 720 torr, so the volume in the bag changes, so the air in the chips matches that atmospheric pressure. And that's what happens in confined containers that are able to expand or contract, that when the pressure in the atmosphere increases, well, then you might have, if it was a balloon, the balloon wants to adjust and have the same pressure. Well, if it needs to increase in pressure, what happens to the size of the balloon? It decreases, it gets smaller, right? If it's a smaller volume, then the inside goes up. Or if you go into Flagstaff, where the pressure is smaller, well, if you need the pressure inside your bag to decrease, but all that air is trapped in there, how are you going to get the air in the bag to decrease? It expands. It's a bigger volume. Anyways, so what is our new volume of our bag? Well, like I mentioned, we have 1 ATM and 720 torr. It doesn't matter which one we use, torr or ATM, we just have to convert them both to the same units. So again, I like to write down what I know. I notice that these are different, and so my first step is going to be to convert them. 720, this shouldn't say kilopascals, this should say torr. 720 torr, and I want the units of torr to cancel out, right? Looking back at our conversion factors for pressure, we know that 1 ATM equals 760 torr, and so I divide 720 by 760. Now, when I do that, if I look in the problem here, notice that 1.2, this is our least number of sig figs. So I'm going to eventually round my answer to 1.2 sig figs. So what I did here is I rounded this to 2 extra sig figs. I rounded this to 4 sig figs because I don't want to round and round again. Right, so I have my pressure in ATMs. Now I have 2 pressures in ATMs, and I can do my P1 V1 equals P2 V2. So we've got our initial pressure and volume, right? 1.2 times 2.1 equals our new pressure to 2 extra sig figs in ATMs, and now I'm going to do my math, right? So 1.2 times 2.1, divide that by the 0.9474, and then now I'm going to take that V2, and even though my calculator gives me this long number, I need to round it to sig figs, right? It's got to be 2.72 sig figs and put in those units of liters. So that's it. You should be able to do the last 4 problems on Boyle's law. Make sure that you are writing out your equation, showing your work, and give me your answer to sig figs and units. If you do have to do a unit conversion like we did here, you do have to show that work also.